So for this stage 2 of the Preppin Data Tableau Conference Special Challenge, we're going to be bringing in a few additional data sets, and we're ultimately trying to understand which animals aren't in their ideal habitat, and so which ones should we go and prioritize, making sure that all their conditions are appropriate at the zoo. So first of all, from our output of stage 1, then this is how it's looking at the moment. And let's just take a look at that habitat field. And we realize that some animals or plants can have multiple different habitats. They exist in multiple different locations, basically. So we want to get to a stage where we can assess each of these individual habitats. So we're going to split up this habitat field by a comma. So going to that option here, split values, custom split, comma, changing this split off to all instead of first, and then that'll create lots of different fields for us, because some animals or plants can be in really basically any habitat, which is crazy, right? They're very versatile. But then we're going to pivot this, so pivot all those split fields that we have, and in order to do this, I'm actually doing a wildcard pivot, so I'm just going to add in a new pivot step to show you what I mean there. So we're doing a columns to rows pivot, and I'm using this wildcard search to pivot option and looking for any field name that has a dash in it, because all of these split ones have a dash in them, and hitting enter, and that just pivots all of these fields without me having to kind of manually drag them over. I'm always looking for things that are going to save me a little bit of time, for sure. We see we've got quite a lot of empty rows here, empty values, and that's where a wildlife species doesn't have multiple habitats. So in all of the other fields names for like split 2, split 3, they're empty. So we can just exclude these values as so, because they're not containing any useful information for us. And we can get rid of this field here as well, this pivot one names. It doesn't really matter what order those habitats are coming in. So that's all that we've done in this pivot step here. And now we need to think about that San Diego climate. So when they're at the zoo in San Diego, what temperatures are they being exposed to? So let's take a look at this table here. So we've got what month it is, and then we've got the highs and the lows in centigrade and Fahrenheit. So it's your choice for the challenge, whether you want to work in centigrade or Fahrenheit. I decided to work in Fahrenheit for the fact that San Diego Zoo is in the US and they use Fahrenheit there. So I chose to be respectful for that, but I absolutely wouldn't blame you if you chose to use Celsius, because that's what you're more comfortable with. Because to be honest, 66 degrees Fahrenheit doesn't mean a lot to me. But if I look at what that matches up to in Celsius, that is 19 degrees Celsius, and that means I understand that a bit better. But anyway, we want to reduce this table down to just one row where we find out the maximum and the minimum temperatures that could be possible in San Diego. So we use an aggregate step to do that, and we're just taking the maximum of the high in Fahrenheit and the minimum of the low in Fahrenheit. Of course, if you were using Celsius, it would be the other two fields there. And then we find out that this table is only one row, and there's nothing in common field-wise with this table here, which has lots of different fields. So how are we going to join those two together and get that information associated with all those wildlife species living at the zoo? So we introduce this dummy field, and this is just the value of 1, and you can see that this value is just repeated across every single row in the table, and we create that in this table as well. And then when we join on that dummy field, then we can see that those values, those temperatures, then just get repeated on every single row of the table. So now we have our highs and lows for San Diego, which is great. As for the habitats themselves, let's take a look at them. So we've got a row for each habitat, and then we've got some information about their maximum temperatures here. And again, these are in Fahrenheit and in Celsius, so pick whichever one is preferable to you. Again, I'm going with Fahrenheit, so I will just keep anything before that opening bracket. And so using our split values, custom split again, just take anything first part before that opening bracket is what we're taking in this instance for both the max and the min temperature. And that's what I do here. So I've done that for the minimum, and then I'm just left with all that text there. And then I clean this to get rid of any letters. and then I just change this to a numeric data type. So remove all those letters, change it to be a number, and then I can get rid of the original field there. There we go. Same for the maximum temperature, very similar process, and there we go. So then I join these together on the habitat field, making sure that I'm joining to the split up values, so it's only one habitat per row. Lovely. And then what I want to do is for each of these wildlife species, I want to know what is the max temperature that they naturally exist in and what is the min temperature that they naturally exist in. So very similar to what we did back here for the San Diego climate. We're taking the max of the max temperature, the min of the minimum temperature, and we're just grouping by our wildlife, name, status, that habitat. Mine's been renamed as habitat-1, where it lists out all the different habitats they can exist in, the class, the region, and don't forget our San Diego highs and lows as well there. So now we're back to our 326 rows, which that's what we want to be at, which is great. Cool. So now that we know where they naturally exist, the temperature ranges, and we can compare this now to San Diego. So in order to compare to the degrees outside the ideal, then we're just doing an if statement, seeing if that San Diego low temperature goes below the minimum temperature of the habitat. Then we want to find out how many degrees it goes below, so low minus min temperature. And then similarly, if the high of San Diego goes above the maximum temperature of the natural habitat, then we're doing the high of San Diego minus the maximum temperature, so we find out how many degrees it goes over. But if it doesn't go outside these ideal ranges, then we just want it to be 0. And that's how we get to this field here. And then we just create our habitat notes field, which is saying if the degrees outside ideal is equal to 0, then that's the ideal temperature. If it's below 0, then it's below, otherwise it's above. So we just have that more wordy categorization there to go along with our numeric categorization. And then we're going to take the absolute value of that, because that's going to help us with our prioritizing our care. So we just wrap that degrees outside ideal in an absolute function, so that the minus 19 and minus 18 go to be positives there, because it doesn't really matter if it's below or above in terms of what we're trying to prioritize here. We just want to know how many degrees. And then we bring in our care priority table, which just has our statuses and the priority number associated with them. We join those on the status, making sure that we do a right join here in the case of how I've joined my data together, so that these values here, which do not have a status, where is it? I'm trying to find the status. It's not showing me the status in this preview here, but basically it's these rows. Let's just go find them. These rows here that don't have a status currently. As per the challenge, we're just going to replace that priority status with a number 6 instead. And then finally, we're just filtering our dataset to exclude the ideal, the animals or plants which are already at our ideal kind of temperatures. And then we're going to apply a rank. So a dense rank with the priority in ascending order, so those who are most endangered are obviously the top priority, and then we'll go and check those by how outside of their ideal habitat range they are by having this additional measure here, the absolute degrees outside ideal, in descending order. And that's our priority order. And then finally, we just want to make sure that if that status is null, then we get a null value for the priority order, because those are unknown. We don't really know how to prioritize those. Those would be a separate piece of information for the zoo. Otherwise, keep it as it is. And we just remove unnecessary fields and we're left with our output. So hopefully that was a fun challenge, and thank you very much for watching.